Stimulating Neural Plasticity in Psychotherapy. This briefing document summarizes the key themes and concepts presented in Chapter 20 of Cozollino-Stimulating Neural Plasticity. The chapter explores the brain's capacity for change throughout life, the factors that influence this plasticity, and the implications for psychotherapy. Core theme. The central argument is that the human brain is remarkably plastic and capable of significant change well beyond traditional sensitive periods, making psychotherapy a powerful tool for facilitating neural restructuring and positive outcomes. Key ideas and facts. Challenging the static brain model. The chapter directly challenges the older view of the brain as a static entity whose development is largely predetermined by genetics and early experiences, as suggested by early studies on imprinting and critical periods in animals. The old view of the brain as a static entity necessitated that the development of psychotherapy be independent from the biological sciences. Fortunately, current neuroscientific research discovered a brain capable of constantly adapting to new challenges. It turns out that extracting the concepts of imprinting and critical periods from ethology and applying them to human development can be quite misleading. We now know that genetic expression is controlled by experiences throughout life, that changes in the environment, both good and bad, continue to have positive and negative effects on us, and that our brains are more plastic. Lifelong neural plasticity. The brain retains its capacity for change throughout life, with ongoing neurogenesis, neuroplasticity, and epigenetic brain building. The adult brain is capable of new learning and adaptation, albeit with an increased tendency towards neural stabilization compared to earlier sensitive periods. As neuroscience finds more examples of neurogenesis, neuroplasticity, and ongoing epigenetic brain building, there's an increasing recognition that we retain neural plasticity throughout life. Rather than lacking plasticity, the adult brain is now seen as having an increased tendency toward neural stabilization while retaining the ability for new learning. Use-dependent plasticity. Learning and adaptation are fundamentally linked to the concept of use-dependent plasticity. The brain physically changes in response to experience, with synaptic strength, neural circuit organization, and functional network relationships being modified. Examples include changes in cortical representations in violinists, braille readers, and taxi drivers. Plasticity refers to the ability of neurons to change the way they relate to one another as we adapt to the changing demands of life. It has been demonstrated that portions of the cortex involved in sensory and motor functions reorganize in response to changing uses after injury and during skill learning. Enhancing plasticity. While future biological interventions like the use of neurotrophic factors, BDNF and T3, and NMDA receptor enhancers like D-cycloserine hold promise for explicitly stimulating plasticity, day-to-day behaviors and interactions already influence this capacity. What if neuroscientists could learn how to reinstate sensitive periods in adults during psychotherapy? Future research with these biological subcomponents of learning and memory may lead to pharmacological interventions that could enhance the brain's ability to learn. The power of enriched environments and stimulating lives. Research on both animals and humans demonstrates that enriched and challenging environments promote neural growth, complexity, and resilience. This includes improvements in brain structure, neurochemistry, and cognitive function. The concept of cognitive reserve highlights how stimulating lives build more neural material, potentially mitigating the effects of aging and disease. It has been known for decades that enriched and stimulating early environments can have a positive long-term impact on both neural architecture and neurochemistry. An enriching environment enables mammals to build larger, more complex, and more resilient brains. The cognitive reserve hypothesis suggests that stimulating lives build more neural material, and the more you build, the more you can afford to lose and still function in a competent manner later in life. Moderate states of arousal. The inverted U learning curve, optimal learning and neural plasticity occur at moderate levels of arousal, not too low, lack of motivation, and not too high, stress-induced shutdown. This principle, formalized as the Yerkes-Dodson Law, reflects the interplay of neurochemical systems like cortisol, norepinephrine, endorphins, NMDA receptors, BDNF, which enhance learning at moderate arousal and inhibit it at extremes. Knowing how to find and keep clients in learning's sweet spot is a vital element of the art of psychotherapy. A state of mind somewhere between the two appears optimal for new learning and complex problem solving. At moderate levels of arousal, these and many more systems enhance learning, while at high and low levels of arousal, learning is inhibited. Attachment plasticity. While early attachment experiences are impactful, attachment schemas are not fixed or hardwired. They are malleable and can change throughout life, influenced by positive social input and new relationships. This has significant implications for psychotherapy, suggesting that healing relationships can facilitate the development of more secure attachment patterns. Our enthusiasm about the power of attachment categories to explain emotional development often fails to acknowledge the considerable fluctuation of attachment schemas. The powerful shaping experiences of childhood can be modified through personal relationships, psychotherapy, and increased self-awareness. The major implication for psychotherapy from all of these findings is that insecure attachment is subject to change as a result of positive social input. The power of a healing relationship, the placebo effect relationships, particularly the therapeutic alliance, have a profound impact on the brain and healing outcomes. The placebo effect, or meaning response, demonstrates the mind's ability to influence the brain through social interactions, expectation, and belief. This involves top-down cortical modulation of mood, emotion, and even the immune system. Because our brains are social organs and interwoven with the brains of those around us, relationships have the power to heal us. Through the installation of optimism and hope, a therapist or any healer uses powerful mechanisms of mind to reshape the brain. The placebo effect is a social phenomenon that likely activates the same reward systems, dopamine, serotonin, endorphin, triggered by loving touch and the anticipation of positive connections and feelings. Psychotherapy as a neurobiological intervention. The techniques used in psychotherapy, such as modulating stress, providing a safe and stimulating environment, and fostering a positive relationship, are inherently neurobiological interventions that enhance neuroplasticity and promote positive brain changes. Psychotherapy is successful in large part because of the therapist's empathic abilities and the client's belief in the therapist's humanity and skill. Psychotherapy is on the verge of an exploding new paradigm, the psychotherapist as neuroscientist. It is quite possible that the caring, encouragement, and enthusiasm of the therapist also reinforce learning, neural growth, and plasticity through the enhanced production of dopamine, serotonin, and other neurochemicals. Implications for psychotherapy. The understanding of lifelong neural plasticity fundamentally changes the perception of psychotherapy. It is not merely a psychological intervention, but a powerful tool for actively reshaping the brain. Therapists can utilize principles of moderate arousal, create enriched environments, and leverage the power of the therapeutic relationship to stimulate neural growth and facilitate positive change in clients, even years after challenging early experiences. The emerging research on enhancing plasticity through biological means further highlights the potential for integrating neuroscience and psychotherapy in the future. Convert _core text convert to source.